Okay, so for this last problem, you can see that the handwriting is a lot better. That's because Dr. Rackvick wrote this solution and not me, and he writes much nicer than I do. So this is on DAC with DMA. It says consider the following analog waveform. We're sampling at a 1 kilohertz rate with a 3-bit quantizer. The input voltage is -1 to +1 volts, and the sample values are then fed to DAC at the same exact rate, so at 1 kilohertz as well. The part A is please sketch the reconstructed waveform at the DAC. So sort of a multiple step problem. We're basically trying to analyze what the ADC would do and then convert that to what the DAC would do. So as we sample with ADC, the first thing we're going to do is figure out how fast along the x-axis we're going to sample. So time scale here is in milliseconds. We're sampling at a 1 kilohertz rate. So we're sampling 1,000 times per second. 1,000 samples per second is what kilohertz means, or 1 kilohertz means. And we have 1,000 milliseconds per second. So that means if I sample every millisecond, I am sampling at a 1 kilohertz rate. We can also do 1 over 1 kilohertz and you convert that into period, which gives us 1 millisecond. So we're going to have a sample point at every line on this x-axis. So we're going to sample at 0, 1, 2, 3, 4, 5, 6, 7, and 8. And you can see that's where he drew these dots. So we draw a dot at each line here, not considering where the wave is changing or anything like that. We're just kind of brute force doing this in the dumbest way possible, just putting a dot on that vertical line at 1 millisecond each. We're quantizing at 3 bits, which means we're splitting this y-axis up into 3-bit values. So 0, 0, 0 is our smallest, 1, 1, 1 is our largest. We have 8 total values that we're going to do this with. So we're going to have 4 on the bottom half, 4 on the top half. And that's what our voltage is going to be sampled as. So that's the digital value we're going to give each voltage. So we have basically just numbering up 0, 1, 2, 3, 4, 5, 6, 7, 8 in binary, 6, 7 in binary, starting from 0 at the bottom. That's the digital value. So if I said, what is the output of this in the sort of digital words, this would be 0, 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0. However, we're asking to reconstruct this as what the DAC would output, and the DAC is basically going to output the middle voltage of whatever range this was in. So in this case, this is a 0, 1, 0. It's going to output at that exact middle voltage for seconds 0 or milliseconds 0 to 1. Then for the next point, it's going to output in the middle of that voltage. So we're basically just changing this into a step function based on what interval it was in that period of time. So that's really all that's happening here, because the DAC is generating a digital value, or taking a digital value, turning it into a voltage. It doesn't really know where within that voltage range it actually was, but it's able to basically generate that middle voltage to approximate what it should have been. And keep in mind that in our case the DAC actually has 10-bit values, so it's dividing those 2 volts in this example up by 1,024 values instead of by 8 values. So there's a lot higher resolution whenever we do this in practice. Okay. So part B, if you were to use DMA to transfer the samples out of the DAC out to the DAC at a 1 kilohertz rate, what would you need to set DAC count val to? Assume a peak clock of 25 megahertz. So we're doing things at a rate of 25 megahertz, which means 25 million cycles per second, right? We want to transfer at a rate of 1,000 samples per second. So we're basically just going to divide 25 megahertz by 1 kilohertz. And that gives us our sample or our cycle count of 25,000. So basically every 25,000 cycles, I'm going to put a new value in the DAC. And when I'm running at a rate of 25 megahertz, if I divide that by 20,000 or 25,000 cycles, 25,000 cycles or 25 million cycles per second divided by 25,000 cycles gives us a frequency of 1 kilohertz that we're sending those samples at. So that's really all that's going on here, is just combining these two numbers in the proper way to figure out what the count val is. So that's it. I hope this was helpful. Sorry it's not quite as good as me writing down the answers as I talk through it, but with the given time frame and my lack of a working printer at home, this is the best I could do. So good luck on the exam. See you tomorrow.